Hi everyone, today I'll be presenting this topic sparse matrix representation in C. My name is Ayush Chakraborty and this is for the subject problem solving using data structures. So what is a sparse matrix? A sparse matrix is a matrix in which most of the elements are zero, storing all these zeros explicitly in both inefficient in terms of memory and unnecessary computation. Hence we use optimized ways to store only the non-zero elements. So there are three common sparse matrix representation. The three-tuple format, also known as coordinate list, compressed sparse row, CSR, compressed sparse column, CSC, and dictionary of keys, DOK. In this presentation, we'll focus mainly on the three-tuple representation. So three-tuple format example. So here's a matrix 100, 002, 030. In the three-tuple representation, we store only the non-zero elements along with their row and column indices. So the matrix becomes 001, 122, and 213. This way we save a lot of space and focus only on meaningful values. The advantages of sparse matrix representation. There are many benefits of using sparse matrix representation. We can save a lot of memory by skipping zero values. Arithmetic operation become much faster since we operate only on non-zero entries, and it reduces output input overhead when storing or loading matrix data. So here's my C program based on three tuple representation of sparse matrix. So we start by defining a structure called element to hold each non-zero value with its row and column. Then a sparse matrix structure holds the size of the matrix and an array of such elements. Then we create a sparse matrix like a function, a 2D matrix, and it converts it into sparse format. We loop through each element. If it's non-zero, we store its row, column, and value into the sparse matrix array and increment the count. Then there's the display function, display sparse matrix, which simply prints out the sparse matrix in three tuple form, row, column, and value for each non-zero entry. And then there's a main function. We define a 4 by 10 matrix with a few non-zero elements. We then call the functions to create and display the sparse matrix. This is how we convert a regular matrix into a compact memory efficient format using our code. So here's the output of the program, shows the sparse matrix in three tuple form. Each line displays the row index, column index, and value of a non-zero element. This confirms that our program is working correctly. So this concludes our presentation. Thank you.